Hey everyone, my name is Divya Talasra. In today's video, we're going to be going through this problem. I got this problem from the first year mathematics exam here at Cornell University. And in this video, I'm going to go over not only my solution, but also general approaches to these type of math league problems, what you should do, what you shouldn't do, and things like that. Usually, math league type problems like this one over here require almost no knowledge whatsoever. They don't require any memorization of formulas or anything like that. Usually if you know addition, subtraction, basically very, very basic algebra, you should be good. The unique things about these type of problems is that they require very high levels of thinking. So yeah, let's get started. The question says, you're given a line of n identical coins placed either heads or tails up. For every coin that shows heads, you count the number of tails to the left of it. Adding up all of these numbers, you get 136. Then for every coin that shows tails, you count how many coins show heads to the left of it. Adding up all of these numbers, you get 153. If the first two coins are heads, tails, find n. Before we even worry about the problem, let's understand what these first few sentences actually mean. So here I have an example sequence of heads and tails. In this example, I have 1, 2, 3, 4, 5, 6. I have 6 coins, so my n is 6. And I'm gonna go through the second sentence. It says, for every coin that shows heads, you count how many coins show tails to the left of it. Now, starting with the first coin, it's heads, but since it's the first coin, there are no tails to the left of it. So for this coin, I'm going to assign it the score 0. Now, I'm just going to refer to the number of tails to the left of any head as the score. That's my own terminology I'm bringing in, so I can explain the problem better. Moving on to the next heads, there's 1 tail to the left of it. For the third heads, there's also only 1 tail to the left of it. And the last heads has 1, 2 tails to the left of it. Now the problem says, adding up all of these numbers, you get 136. So in our case, in our sequence, when I add up all of these numbers, 0 plus 1 plus 1 plus 2, I get 4. And I'm going to call that the H-score. So I get my H-score by simply adding all of the scores for each head. So in this sequence, my H-score equals 0 plus 1 plus 1 plus 2, which is 4. It then says, for every coin that shows tails, you count how many coins show heads to the left of it. We're going to be repeating the same exact steps, except now for tails. The first tails appears here. We have 1 head to the left of it, so its score is 1. Moving on to the second and last tails, we have 3 heads to the left of it, so I'm going to assign it a score of 3. Now, it says adding up all of these numbers, you get 153. But in our case, adding up all these numbers, which is just 1 plus 3, you get 4. And I'm going to call this the T-score. Now that we have the terminology set in, we can go back to actually trying to figure out how to approach this question. Now, before we actually get started, a piece of advice, never ever try to do more than what's being asked in any math league type problem. For instance, in this case, the question is asking us to find n. It's asking us to get a number. That's it. Do not whatsoever try to generate the sequence of heads and tails that ends up having a H-score of 136 and a T-score of 153. That basically just involves guessing and checking. There's no thinking involved, and that's not what these type of problems are testing you about. So never do what's more than being asked, because you're usually going to take the wrong approach, and it's going to take too much time, and you're probably not going to even end up with the right answer at the end of the day. So if you feel like you're taking way too much time, think of a smarter approach, because if you think of a smarter approach earlier on, getting the answer is much easier and much faster, obviously. So before I worry about the question, I'm going to go over the basic definition of multiplication. And you're probably confused as to why I'm doing this, but in a few minutes, it's going to make a lot of sense. So if you had to explain how to do 3 times 2 to a 5-year-old, how would you do it? Well, let's see. You could describe this as follows. Imagine you have 3 red balls, so R1, R2, and R3. And let's say you have 2 green balls, so G1 and G2. Now, how can I visually represent 3 times 2 with this diagram over here? Well, for every 1 red ball, I can map each red ball to every green ball I have here. So 3 times 2 is basically mapping the first one you have in 3, so the first red ball out of the 3, to each green ball. So I have 1 here, 2 here. Doing the same thing here, I get 3, 4, and then here I get 5 and 6. Now the lines look a little messy, so I'm just going to rewrite this. So first I paired R1 with G1, and then R2 with G1, and then R3 with G1, and then I go ahead and pair everything with G2. So R1 with G2, R2 with G2, and then R3 with G2. And as you can see, I end up with a total number of 6 pairs here, which equals 3 times 2. So the total number of pairs, equals the total number of elements on the left side times the total number of elements on your right side. So I'm just going to give all the elements on the left side a name. I'm just going to call it the domain. And I'm going to call all the elements on the right side the codomain. If these terms seem unfamiliar to you, don't worry about them. Just know that everything on the left side is the domain, and I have 3 elements in my domain, and I have 2 elements in my codomain. So as I said, the total number of pairs I end up with if I map each element in my domain with every element in my codomain equals the number of elements in domain multiplied by the number of elements in my codomain. Now, this is a pretty intuitive fact, but this is crucial for approaching this problem. Now that we have the basic definition of multiplication down and a way to visually represent it, I'm going to go back to the question and show why this is applicable to the question. Essentially, what we're going to do with the question and how we're going to relate this back to the question is, instead of red balls, we're going to have heads on the left side. So our domain will have the number of heads in the sequence, and our codomain will have the total number of tails in the sequence. So let's do that. And once again, I know it's still not clear where I'm going with this whole multiplication thing, but just give it a few minutes. I'm going to stick to my example sequence right here. In this example sequence, I have 4 heads and 2 tails. So I'm going to do H1, H2, H3, and H4 on the left side. So these 4 heads make up my domain, and on the right side I just have the 2 tails. So T1 and T2. And I'm going to write out all the possible pairs I end up with when I map every single element in my domain with every single element in my codomain. And the total number of pairs I should end up with should be 4 times 2, so 8 total pairs. So I'm going to list them all out here. So first I'm going to map H1 with both the tails, and then do the same for the other 3 heads. And as it turns out, we indeed do have 8 total pairs. There should be no surprise there.